We know that we're able to see different objects around us because of light. During the daytime, we are able to see all the different kinds of things. We see the road, vehicles running on it, trees, and we see these things because of the light from the sun. During nighttime, we are able to see the same things, but this time because of the glowing street lights. In the first case, the light is given to us by the sun, and in the second case, light is provided by the street lights. Objects which can generate their own light are called luminous objects, whereas the objects which cannot generate their own light are called non-luminous objects. Sun, stars, light bulbs are some of the examples of luminous objects. While the cement road, the steel pole, the trees and the benches are non-luminous objects. The human body is also non-luminous. We cannot generate our own light. Most of the objects that we come across in our day-to-day life are non-luminous. The book, the pen, wood, and so on are non-luminous. So how are we able to see the non-luminous objects? Yes, you will say that we see them because of light. Yes, that's correct. But the more precise answer is we see non-luminous objects because of the reflection of light. The light bounces off their surfaces. The reflected light, when reaches our eyes, enables us to see them. Now, where is this light coming from? Well, it's coming from the luminous source, the sun in this case. So we can say that the non-luminous objects reflect the light of luminous objects, and this reflected light is what helps us to see them. The light after reflection is traveling in a certain direction. And this direction is not just any random direction. Yes, if the incident light is in this direction, then the reflected light will always be in this direction. And this concept is nothing but the first law of reflection. Yes, light obeys some laws of reflection. We will understand those laws in our next video as they require some detailed explanation. But for now, we will discuss one important characteristic of light, and that is light always travels in a straight line. This observation was first postulated by Euclid in around 280 BC. You can also try to demonstrate the same thing at your home. Take two pipes, one which is straight with no bends and the other which is bent in the middle. Now look at the flame of the candle through an open end of the straight pipe. You will see the flame clearly, which is not so surprising. Now see it using the pipe which is bent. You wouldn't be able to see anything clearly. Use different pipes that are bent in different ways and try to look at the flame through each of them. Again, you wouldn't be able to see the flame through any of them. What does this imply? Well, from this we can imply that light takes a path of a straight line. Otherwise, we would have been able to see some or all of the light through any of the bent pipes. This fact is, however, not quite entirely true. Einstein predicted that light can be bent by gravity. And it has been observed that during total solar eclipse, when the moon is between the Earth and the sun, the light from the stars present behind the sun is visible to us. Well, it shouldn't be if light travels in a straight line because it should be blocked by the sun. But this happens because of the light coming from the stars is bent by the gravitational field of the sun. Light is also bent by the gravitational field of the Earth. However, the sun being 1,000 times bigger than the Earth has a more massive gravitational field around it, and hence it bends the light by a comparatively greater degree. The Earth's gravity deflects the light by about 1/1,000,000th of a degree. That is really small. Hence, for our purpose, it's perfectly fine if we think of light traveling in a straight line. Because of this, we can think of light as straight line paths with arrowheads traveling in different directions. A light source emits light in all possible directions. For example, this fluorescent glowing bulb is emitting light in all the possible directions. All these lines with arrowheads are called light rays. You can think of a light ray as an infinitely narrow beam of light. In reality, a ray of light is something which is not visible. This is just a way of explaining how light travels. A straight line with an arrow in the direction of propagation. It is easy to draw a ray of light on a piece of paper, and this depiction of light is very useful. Understanding light as rays in different directions, we can study the properties of images formed by mirrors. We will see them in our future videos. We will start with the reflection of light in the next video.